This video, I'm going to go over the first and second of Newton's laws, and my partner is going to go over the third law. Today, I'm going to use this basketball to help me demonstrate Newton's first and second law. Newton's first law. This law is also known as the law of inertia. Inertia is simply an object's resistance to change in the state of motion. When you go to perhaps kick a soccer ball, there's inertia at play, as well as when an object is simply standing still. On the floor is also inertia at play. An object is simply resisting motion thanks to inertia, stated in Newton's first law. This law does state that an object at rest will remain at rest. If I take this ball and place it on the floor, it won't move, it will remain at rest. Now, if I were to act on the ball, it'll move. As you see, it rolled out of frame. Now let me roll it back in the frame. Because I'm acting on the ball, it's moving. There's an external force causing it to move. I'm moving the ball while we're moving the ball on my feet. When I dribble the ball, I'm acting on the ball. Pushing the ball down, and it's exhibiting an equal and opposite reaction to come right back. Have Newton's second law. Newton's second law states that force is equal to mass times acceleration, or force equals ma. Ma stands for mass times acceleration. This states that the net force on the ball is directly proportional to the ball's mass. So, let's say I were to drop the ball. When I dropped the ball, it did not bounce right back into my hand because I did not put force into it. I just let go of the ball. Compared to if I held the ball up, the ball came all the way back up because the net force I used in my second attempt was much greater than my first attempt. This applies both horizontally if I were to throw the ball at the wall very softly, it bounced. But if I were to put more force into it, it came back because I put much more net force into it.
I am going to demonstrate Newton's third law that for every action force, there will be an equal and opposite reaction force. So when I apply the action force to the wall, it gives me back the opposite and an equal reaction force. This is why I don't fall through the wall, and because the wall is giving me back the same force that I applied to the wall.